Hey there everybody, Mr. Dickin here. In this video, we're just going to do a quick little recap of what we've learned thus far with quadratics. Quadratics, remember, are U-shaped graphs, aka parabolas, and what we are particularly concerned about is the vertex of these things, the x-intercepts of these graphs, and then also the y-intercepts of these graphs. So we've learned a variety of different ways to find all of these things, but when it all boils down to it, these are the key pieces that we're looking for, those interesting points there. All right, so first and foremost, you guys all had access to the review worksheet. Now I'll have the digital copy of this with the answer keys included available to you. One thing that I do kind of want to highlight, even though it is highlighted here on the form, is make sure that you're paying attention to the format of the answer, especially on softwares like MathXL. If you have the correct equation just written in the wrong form, it's not going to count it as being correct. So make sure we're writing things in vertex form if it's asking for vertex form, or standard form if it's asking for standard form. I completely realize that it might be easier to just leave this in vertex form, but here, if it's in standard, we have to distribute that out and solve accordingly. Another thing that I want to point out, especially on problems 6, 7, 8, and 9 here, is make sure you're paying attention to which solution it's asking for. So with all three of these, four, counting's hard. With all four of these, essentially all you're doing is just setting it equal to 0, right? Set it equal to 0, factor it, and then solve each factor for x. That's really it. But you're not going to just spit out both answers. You have to pay attention to what the question is asking you for. The reason why we're doing this is on tests like the SAT and ACT, you'll see problems just like this, where it's not going to ask you for the answers. It's going to say, what is the product of the two answers, or the sum, or the difference, what have you. And the reason they do that on those tests is it prevents people from kind of working backwards using guess and check on a multiple choice. So just something to keep in mind. All right, now let's get into just a handful of quick problems, and then we'll go from there. Example 1, we've seen one just like this previously. A parabola has 5 as its only 0, so I know that the point 5, 0 is on this graph. That means x minus 5 has to be a factor. I want to write the equation of this parabola. It doesn't tell me what form that equation has to be. However, the fact that it's a parabola means that I have to have an x squared somehow involved. Well, if I had 5 as my only 0, I can't just say, hey, let's multiply this thing by another x. That way, when we distribute, we'll get an x squared. Because this x here tells me that there's an x-intercept at 0, 0, which is not true, because 5 is the only one. So really all I have to do is just duplicate that. So I have that same factor written 2 times. I could also write that as x minus 5 quantity squared. That's also legal. Now this problem did not specify what format it wants the equation in. So I've got the freedom to say, hey man, you didn't tell me what format, so I am going to choose intercept form or factored form. If it did mandate, and a lot of times it will, standard form, this is what it would be. And this is just from distributing that thing out. So f of x equals x squared minus 10x plus 25. All right, next one. Given that 4 is a 0 of a polynomial or of a quadratic, solve for the missing value. So they told me that I have a point 4, 0. Well, they just gave me an x and y value. If I know an x and y value, guess what I can plug in for x and y up in that equation? Well, whenever I see an x, I can plug in a 4, so a 4 would be there and a 4 would be there. And whenever I see a y, I get to plug in 0. So if I do that, this would look like 0 equals 3 times 4 squared plus b times 4 minus 8. Well, now it's just simple arithmetic, right? Let's see, 0 equals let's see, this would be 3 times 16. Correct me if I'm wrong, but that'd be 48, I believe. 48 plus, I'm just going to call that 4b instead of b times 4, minus 8. We will combine our like terms here. I've got 48 and a negative 8. So that is just 40 plus 4b equals 0. B would equal negative 10. Not too shabs. Not too shabs. All right. The next one is one that I used Desmos on. Now, you could do this, by all means, you could do this problem on a TI 84 or 83, whatever you have. I don't have one of those on my iPad, so I've got Desmos, so I'm using Desmos. And I like Desmos way better, so I'm using Desmos. We have a baseball hit into the air, and they're giving us an equation. Now, as soon as they give you an equation, if you graph that, you can figure out everything you need to know. So you'll see I put that equation into Desmos. Nothing fancy about it. The only difference is I just used x instead of t. Not that big of a deal. And then I also had to kind of pinch and stretch my axes, so that way I could actually see the graph. If you're doing this on a TI calculator, you'd have to go into your window settings and go from there. So there's only a handful of things that we really care about with these, right? Where did it start? So it started at 6 feet off the ground, and you'll know because that's the y-intercept. It's always your starting height. How high did it go? Well, that's the maximum. It went 202 feet, and it took 3.5 seconds to get there. And then when did it hit the ground? So those are the only aspects that we can possibly care about. I don't care about anything back here because in the context of the problem, it doesn't make sense that a baseball would A, travel back in time, or B, go underground. So let me move this out of the way and let's see what this thing's even asking. How high is the baseball after 1.5 seconds? Holy smokes. Well, we didn't solve for that, did we? If I look at my graph, let's see, this would be 1 second here. So this would be 1.5. I'm going to ballpark that and say it's probably going to be like 130-ish. But if I wanted to know for sure, I would just plug in 1.5 for t and see what I would get. Well, if we plug in 1.5, hey now, we'd get 138 feet. Well, yeah, I could see that. My guess was 130. I'll give it 138. Next, will the baseball ever reach 250 feet? Explain. Well, the highest this thing goes is 202. And it's never going to get any higher than that. So I don't know about that 250. Nope, it won't. It will never go higher than its maximum. Hence the word maximum. Next up, after how many seconds will the baseball hit the ground? Well, that's this point right over here. And we already have that answer. 7.05 rounding seconds. So that thing has some decent hang time. All right. And by the way, all of these points, if you were to graph this on Desmos, if you click the graph, it'll pop these little dots on there for you. You just have to click it, and it'll tell you the answer. And this is going to be our last and final example here. Jacob wants to put a deck along two sides of his garden. The width will be the same on both sides. So that means the width here is going to be the same as the width here. Okay. The total area of the garden cannot exceed 500 square feet. How wide can the deck be? Well, let's see here. It says the total area of the garden. I'm assuming that means all-encompassing, right? Because the garden itself is just 300, right, if I did 15 times 20. So all-encompassing cannot exceed 500. Well, let's mark this thing up. If I think of this as just a jumbo rectangle, this length here would be 15 plus whatever our mystery x value is, and we don't know what that is. 15 plus x. Same logic up here, but 20 instead. So 20 plus x. Okay. Now, I don't know the x dimension. However, I know that we cannot exceed 500 square feet. So I'm going to put equals 500. That's my absolute threshold, my absolute maximum. what I'm going to do is I'm going to take these dimensions of essentially the rectangle that I have. So that rectangle is the 20 plus x and 15 plus x. And I'm just going to multiply those together because isn't that how we find area of rectangles, right? Base times height. So we have x plus 15, x plus 20. Multiply those together, set equal to 500. Our goal is to solve for x. All right, if we distribute it out, x times x is x squared. I'd have a 20x and a 15x, so 35x if I combine those. And then 15 times 20 is 300. So x squared plus 35x plus 300 equals 500. Now, I don't really like having a number on the other side of these, right? And if we want to solve quadratics, typically we want that thing equal to 0. So in order to do that, the 500 has to go. So if I subtracted that over, this now becomes a negative 200 at the end. So we have x squared plus 35x minus 200. At this point, we have to go through and solve this. Now, in solving, we have a few friends, right? We can do factoring. Later on down the road, we'll learn, hey, we could just graph this thing and see what our x-intercepts are. Maybe we could do quadratic formula. There's a whole slew. But ultimately, if I'm factoring, I want to know what multiplies to be 200, but would add up to be 35. Well, if I think of 200, let's see, 200 is going to have a whole bunch of factors, right? It's got 1 and 200. There's no way I can get that to be 35. 2 and 100, still no. 3 doesn't go into it. 4 does. 4 and 50. No, that's not going to do it. It ends in a 0, so I know 5 goes into it. So 5 and 40. Ooh, 5 and 40. I think that could do it. So 5 and 40, I could combine those to get a 35 if the 5 was negative. So I could factor this thing out into x minus 5 and then x plus 40. So I've just factored that quadratic. And now we'll just solve each one, right? So x equals 5, cool. And x equals negative 40. Awesome. So those are my two answers, or are they? This thing was asking, how wide can the deck be? How wide can it be? I don't know about you, but I have no idea what a negative width would be. So negative 40, sorry, you're out. Correct answer here would be 5. So 5 feet in width would be the maximum width we could get in order to maintain that area of underneath 500. All right, that's it. That's all. You know the drill. If you have any questions, let me know. Shoot me an email. Ask me in Zoom, whatever. And as always, folks, good luck. Have fun. Be safe. Roll Tide.